and good morning, good evening to other folks who are joining across from the globe. I'm here, Feroz Khan, a quite long name, Abdul Rasheed Feroz Khan. I'm the founder and CEO of CodeSizzler, a Microsoft partner firm who helps on consulting, training, and migration business, and now into IoT and AI platforms as well, where we work with Microsoft partners to set up their environments, having their infrastructure maintenance, having support on migrations, doing AI and IoT solutions on automated and more and more into the 5G capabilities of IoT as well. So I have my email ID here, and here's a quite short introduction of me. I'm a Microsoft MVP on Azure. I'm a Microsoft certified trainer as well, and a cloud advocate on Azure platform, giving my suggestions on the certifications track, especially for the beta platform. And I hold a 10 years of experience as a cloud consultant. I work more into the three platforms of Azure, AWS, and GCP. And my core expertise was said to be with infrastructure, IoT, and ML and AI steps. So we are Microsoft partners. CodeSizzler works as Microsoft partners. We are based across India and UAE. We are a silver application development recognized firm, and also in the application integration and in your data center as well with Microsoft. With that, I would like to start for today the most biggest event of the Azure platform, Global Azure, happening across the globe. And I would like to thank all my community mates, the community rock stars. The very first one is said to be the Global Azure, the community which runs the Azure platform each and every year with a big shout across the globe, speaking about all technologies on Azure, starting from the IaaS, PaaS, and SaaS. And we speak more about the preview features as well that has been come up into Azure and the roadmap that we have with the Azure platform. We support a lot with other community folks as well to make sure about the other platforms that we have on which you can learn Azure research. And with that, CodeSizzler, who is which is again a firm that supports Dear Azure and a partner of Dear Azure as well in hosting the community events. And Dear Azure, of course, Kasam Shaikh, who is the managing person for Dear Azure, taking care of all responsibilities, hosting the events, lining up the speakers. Not a single job, right? It's going to be like having tons of things to get lined up. And the Microsoft MVP platform, especially the Microsoft MVP India platform, supporting the community events as well on hosting this, not just the Azure events, but also the other community events that we come across. So with that, I would like to take forward for the topic which I'm going to focus for today. So here is the big question of what would be the next 1 hour focus that we're going to have. So if you are going to be active with me for the next 1 hour, I am here going to speak about the device management that we have with Azure IoT. So this is going to be like an intermediate level of conversation that we will be having for the next 1 hour, along with the hands-on as well to make sense about how the firmware can get updated in an automated environment. So I'm here going to speak about like the services that we have with Azure, which we call it as device management and IoT device management. Okay, that is a component of your IoT hub. It also has the device twins and direct methods, which can help you to implement the device management. I'm also going to speak about implementing the device management for various patterns like your device twins, your direct methods, etc., and how to make your automated device management and jobs to be performed as well. Let me start here about what the device management is. See, device management has been grouped into the principles. I would say 4 principles together. The very first thing is scale and automation. And secondly, we have it supporting with openness and compatibility. It also supports you for the context awareness. And finally, with the service that it supports with many roles that can be integrated with. Let's first go with what is this service with scale and automation. See, IoT solutions require like simple tools that can automate the routine tasks and also enables a relatively small operations staff to manage like a group of devices. I would say even a millions of devices at one time. So in day-to-day operators, or I would say the operators would expect to handle the device operations either remotely or you need the millions of devices to be operated in a bulk way and you also need to be altered. Okay, you need to alter the solutions when the issue gets raised. Okay, that requires their direct attention as well. So that's exactly where we go with scheduling automation. You need to manage the devices, right? It can be a small operation or it can be like a firmware update that you need to manage. So you need to manage like millions of devices in a remote way, or you need to do an operation in a bulk way. Okay, so that's one kind of thing, one kind of principle which we can do with device management. And secondly, the openness and compatibility. See, the device ecosystem is an extraordinary service that works in a diverse environment. So you say the management tools must be tailored, okay, to accommodate a multitude of device classes, platforms, and also the protocols. You might say that you have the real-time implementation of your Raspberry Pi, or you might be having Arduino boards. Again, you would say it can be using a Windows 10 IoT Core OS, or it might be even with the open source platforms, right? So the operators must be able to support with any types of these devices and any types of the platforms, from the most constrained embedded single process chips to the powerful and fully functional computers. And then we have the third principle, the context awareness. The IoT environments are said to be dynamic and it keeps on changing. The service reliability is like paramount, and the device management operations must take into the account with the factors like ensuring that you will be maintaining the device downtime, okay, and that does not affect the critical business operations or creating any dangerous conditions as such. So we'll go with maintaining the SLA, okay, with network and the power status of the devices, the in-use conditions that has to be managed, the device geolocations that has to be managed. So all these things will be taken care in this principle, which is said to be context awareness. And finally, we have service many roles. It supports for the unique workflows and the process of your IoT operations roles, which is said to be much crucial. The operations staff must work simultaneously with the given constraints, okay, of your internal IT departments, and they must also find some sustainable ways to surface real-time device operations with information to the supervisors and other business manager roles as well. And the next comes like the life cycle that we have with the device management. With each of these complete five stages, there are several device operators who requires the fulfilled amount of completing a solution. The very first thing I would say, plan. You need to enable the operators to create a device metadata scheme that enables them to easily and do some query, okay, for a group of devices, for a group of target devices, which does some bulk management operations. So that's it to be planned. You can plan the device twin to store the device metadata in the form of tags and properties. So this will be ideally with a JSON representation. And then provisioning, you're going to securely provision the new devices to IoT Hub, and you're going to enable the operators to immediately discover the device capabilities as well. You will use the IoT Hub identity registration here to create flexible device identities and credentials as well. And this will perform the operations in bulk by using a job. You will build the devices to report their capabilities and conditions to this device properties inside your device twin. So provision helps you simply to say that you need to build the devices. Okay, it has to come up with the device capabilities of discovering it, enabling the operators, okay, to perform a job, and to have a bulk job operations to be performed as well. And all these data would be available as a metadata inside your device twin. Thirdly, configuring. You need to facilitate the bulk configuration changes and the firmware updates to the devices while maintaining both healthy and security role to be managed. So you can perform these both things like having the firmware updates, okay, checking the health status of the devices with security. All these things can be managed by using the desired properties or with direct methods under this configure part. And then we have monitoring. Monitoring will be like overall device collection that comes with the health. The status of ongoing operations and alert operators to issues that might require their attention will be there in the monitor. It's going to be like a telemetrics. You will apply the device twin to allow devices to report real-time operating conditions and the status of your update operations over here. We will also build the powerful dashboard reports that's going to give you the most intermediate issue by using device twin queries. And finally, we have retire. You can replace or you can decommission the device after a failure here. You can also upgrade the cycle, or at the end of the service lifetime, you will say that you will retire your device, okay, and you will replace with a new device. You can use the device twin to maintain the device information if the physical device is going to be replaced because of the reason which might say an outage on the device or end of service that we have. You can use the IoT Hub identity registry for securely revoking device identities and the credentials as well. So to work with this device management, you also need to know about the patterns that we have with device management. So these are all like 5 patterns that we have with the device management that helps you to communicate with the backend application. The backend apps can use Azure IoT Hub primitives like the device twins and the direct methods, and they remotely help you to start and monitor the device management actions over the devices. The very first pointer here is patterns. You know that there's something called as IoT Hub, which enables you to have a set of device management patterns, and that patterns like device management patterns is said to be it's like a following set of conditions which helps you to go with reboot, okay, factory reset, configuration, firmware update to be performed, remoting, progress, and the status as well. So here, ideally, what we do here is that the very first thing that we work is you go with a reboot. So reboot is that see the backend app informs the device through a direct method that it has initiated a reboot. The device has to use the reported properties to update the reboot status of the device. And then comes factory reset. The factory reset is often a direct method invocation. The factory reset is where the backend app informs the device through a direct method that is, it has initiated a factory reset. The device uses the reported properties to update the factory reset status over the device. And then you have the configuration. The configuration changes are normally done with the help of your device twin. The backend app uses the device desired properties to configure the software that's running on the device, and the device uses the reported properties to update the configuration status. And finally, we have this firmware update and then the reporting as well. See, firmware update is critically important. The backend app uses an automatic device management configuration to select the device, to receive the update, and to tell the device where to find the update and to monitor the update progress as well. The device is here going to initiate a multi-step process to download, verify, and apply the firmware image, and then reboot the device before reconnecting it to the IoT Hub service. Throughout this multi-step process, the device is going to use the reported properties to update the progress and to set the status of the device as well. We then have the reporting progress and the status. The reporting and progress and status is also often done with the help of the device twins. The solution backend runs the device twin queries across a set of devices to report on the status and the progress of actions that are running on the device. As an overall here, the device configuration with device twins looks like what you see in the architecture. You may notice that 3 of the 5 device patterns were built on top of the device twins, and it looks like more of the device twin configuration process here. The backend app is quite important. The backend app is going to put up the properties. It's going to read from the reported properties again from the device. Okay, and it's going to set the meta tag data, and it will do the set and read operations along with the device as well. Here is about the device configuration with device twins. You need to know like the basics alone. Okay, like what the device configuration is. with related to the device twins information. We have IoT Hub, but within the IoT Hub, we'll be having this device twin on the IoT configuration part. The device twin helps you to briefly go across, okay, having the properties to be managed like the telemetrics, okay, the frequency on which the data has to be sent, the versioning that we have, okay, and the frequency again, like with the status message saying whether the message has been succeeded or you have a failure on it. The next comes backend operations that we perform. Until now, you should have made sense that you have changing the properties in the device twins. You can do the device property changes to be with the manual edits over the portal, but that's not a feasible solution when you say that you will do some manual changes using the portal for a bulk of devices, for millions of devices, I would say. So in real life, this is not going to be a scalable solution. So the device operators will instead use something called as the device management applications, or the other terminology that we use is to be the backend applications. This helps you to manage the device configurations, and this works through the backend operations exposed by the IoT Hub to allow a backend application to change the device twin properties. We then have the device operations. Besides requesting the changes to device twins, you can also request information on device twins. So it can report or it can do the logging purpose, and this falls into the category of device operations. This can include a device request for information, okay, for twin information, or it can even register event change handler that has to be informed with the changes. We finally have the metadata. You people know this. Okay, the metadata is going to be like it's associated with the device twin. The metadata field will explicitly query your update, your timestamps. Okay, well, there's a version field, and it also speaks about the form of metadata that we have. So you see, like we have the telemetrics, you have the frequency on which you're going to send the data, the versioning of the same, and the status as well. Okay, so these things will be available with the metadata. Finally, we have the direct methods that you need to make sense. Okay, so this is set to be I can say it's going to be like a topology. Okay, direct method is set to be a topology. The IoT Hub gives you here the ability to invoke the direct methods on devices from the cloud. The direct method represents a request. Okay, you get a request reply kind of interaction with the device, which is similar to a HTTP call, and they succeed or fail immediately can be updated over it. It's going to be with a user specific timeout. This approach is kind of useful one for scenarios like where you have immediate actions. Okay, you need to take an immediate actions like let's say having a light to be turned on. Okay, and you need a status message whether the light is set to be turned on or you have an outage on the device. Okay, so those kind of things. Let's say you have traffic signals, right? You take IoT automated traffic signals. You want to stop the vehicles at one lane with a red color, and when there's a red color indicates, then the next one has to the next lane has to turn on with a green signal. Okay, or when an accident happens at the roadside, right? The camera has to capture it and it has to send towards the nearest hospital, okay, to pass the messages. So this is all like immediate messaging response that happens with the HTTP call. And then you can use this direct method. So to implement the direct method, you need to be running a standard tier. Okay, you have plans, right? You need to go with a standard tier on your IoT Hub service. The direct methods have the features like each direct method can target a single device. You can use IoT Hub with the jobs to invoke the direct methods either on the multiple device, or you can even schedule the method invocations for the disconnected devices. And next, we have anyone who can connect with the service permissions on a IoT Hub who may invoke a method on the device. You can also have the direct methods which follows a request or response pattern, and that's mean for communication that requires immediate confirmation for the result. There can be an interactive control of the devices, like what I was saying, capturing an image, passing it towards a nearby hospital, turning on a fan or turning on a light, and you need the message to be processed with a status. Okay, so those are like kind of examples where we can use this direct methods. You should have seen in real time, like we have plenty of things. Okay, let me go with this Alexa, right? Alexa is like one kind of example where you get a status message. You say a light has to be turned on with your Alexa, and you get an update, okay, with your saying that the light has been turned on, or you get a like when the device is set to be offline, you still get a message as well. Sorry, I don't know that. So yeah. So these are all like examples, right, where we can use this direct method. And apart from the direct methods, there are also like you have device twins which we can use. Okay, device twin is another model approach that we have with the device management, which does like one way of communication with the device. So if you want to use two-way communication with immediate response, then you can use direct method call. For one way, you will be using device twins. Okay, the frequency of the device twin is said to be medium, but whereas when you call with a direct method, it's said to be with a high frequency. And the size of the payload, okay, is also said to be high. The target can be of high with using bulk devices on a direct method, whereas that's not the case when you use a device twin. And see, the messages can be retained like for a long period of time when you use a direct method. Whereas when you use like device twin, you have a restriction on it. Okay, you have a specific period of time where you're going to say the message retention durability. And the same for the cloud to device messaging, you have another methodology. Okay, like one-way notification that you can process. That's said to be C to D messaging, cloud to device messaging. And there you will get it like 48 hours of time on which you can store the messages. There are also difference with the protocols that it supports for communication. Like direct method will use MQTT or AMQP, and the device twins also will be using the same MQTT or AMQP. So either of these things are not going to support you with HTTP based. Whereas the HTTP URL patterns has to be called from the backend application when you use a direct method. Okay, your IoT hub will be having a backend application, right? So there you need to represent it. So with that, let's move to make sense about exploring how automation can be done with this IoT device management. Here, I'll be making sense with a hands-on. Okay, I'll help you to make sense with a hands-on with having a code to be written for simulator device, creating IoT hub environment, and a code to implement a firmware update as well. Let's say if there's an update that happens for a device, then you should see that it can get automatically updated on the sensors that it has been connected with. We will test the firmware update process on a single device, on a simulator device, okay, using your Azure IoT Hub environment with automated device management here. So let me go ahead with the Azure portal now. So here is my Azure portal. And you see, we would be going up with a IoT Hub to be provisioned up here, okay? So to go with IoT Hub, okay, normally your Azure portal looks like this. Excuse me. Right, your Azure portal looks like this. Let me sign in. Okay, so here, let me try creating a resource group. Right, let's say add a resource group. So let's go with Global Azure Resource Group to be deployed at, okay, East US is fine. Let's go with the same. I'll first create a resource group. I hope you people should be good enough to make sense about what a resource group is. It's like a folder. Okay, it's like a kind of folder kind of thing where you can tag all the resources together over here. Well, we have the resource group created. Now let me go to the Cloud Shell and I'll try deploying a template. Okay, cool. Let's try uploading a template here. I have it on my documents, Global Azure. Okay, let me take up this template. It's listed. See, you can find gap. Okay, setup. Not exactly. It should be with the CLI. Okay, let me change. Let's take this tool. Okay, you find. I'm sorry. See here, you can find the file which is said to be lab 16. Okay, let me take up this. So I just need to change the ID alone. So let me change the ID here. I would say my ID will be gap. Okay, 2021. In location, let's say it's going to be spun up at East US. Okay, it has to be deployed at East US. And resource group, I hope you remember we created a resource group named as GAP, okay, Global Azure -AG. So let's call that Global Azure, okay, -AG. And you just scroll down, you need to change the other values as well. So here also you can find that we have a resource group. You just change this. Let's say Global Azure -AG. Yeah, we are good then. So what this is exactly going to do is that this is set to be a set of command line environments that we have. It's going to create a IoT hub, an Azure IoT hub with a standard plan. And there inside the Azure, see, we are going to create IoT hub. Inside the device IoT hub, we are going to create a device ID, okay, a simulated device which is going to be created within the IoT hub, and we will retrieve the connection string for the same. So let me save this, and I would say make a directory named gap 2021. Okay, and let me go up with moving the file lab16 setup.accli, okay, for gap 2021. And now let's say list, okay, change the directory for gap 2021, and now list it up. Okay, we have it here. Let's give the permission to execute this file. Okay, and I will try running it here. So lab16 setup.accli. So here you should find, see, an IoT hub is getting created. The name is set to be Gap IoT, okay, 220 with training, Gap 2021. Eventually, let's go up here. You can find it. Let's wait for it. So once when this is created, you will get a device connection string. Okay, you need to save the device connection string, which I will be calling it later. Let's wait for it. Eventually, you can let me know if you have any sort of questions until the terminologies which we have discussed right now. Okay, cool. Let's wait for the IoT hub to be created then. Okay, there we go. You can find the device connection string. So let's copy this connection string. Now, actually what has happened here is that, see, you just refresh this, you can find oh, Glow IoT hub. Okay, not here. Let me close this. It should be on another subscription of mine. Okay, let me take this 2021. Can you find this? We have a Global Azure resource group which has been created. And there inside it, you have a IoT AZ220 training, okay, with a gap 2021, which has been created as well. So this is your IoT hub. And there inside this IoT hub only, you're going to align the devices, and the IoT hub can consume the metrics that's going to be having the devices together. So here you say IoT device, you can explore the devices which has been connected to it. Okay, so here inside this, you'll be having the device updates. So this is what we were discussing. You'll be having device updates, you'll be having device twins, everything. And see, this is the sensor, simulated sensor, which I have connected for. Okay, and to consume this, you need a connection string, which has been listed up here. Okay, the connection string of sensor TH0155. So now let's write the code for a simulated device, okay, that implements the firmware update for us. So to write the code, I need a VS Code environment. Okay, so let me go up with a Visual Studio Code. Let me first copy this connection strings. Okay, let me put it on my notepad. Cool. And now let's open up VS Code. So here is my Visual Studio Code environment. I would say go for terminal. Okay, a new terminal to be opened up here. So here in this Visual Studio, go click on terminal. Oops. Yeah. So terminal, and let's say a new terminal. and let's create a directory here. So I'll create a directory, make directory, okay, firmware update, okay, for gap, I would say, gap device. So firmware update for the gap device is set to be a new directory which I'm going to create. I need a solution file to be called with this directory, okay, and excuse me, let's change the directory again with firmware update gap, okay, device. And here, let's try creating a console tab. Let it get created. So now, let's go up. We have this console app which has been created. Okay, and here let's add the packages that we need. So this .NET new console app has to be worked across with the packages, like you need to put up the device client. Okay, you need to say like you will be having a device shared, and we also have the need the library files which has to be added up for the same. So let's say .NET. Okay, add package with Microsoft Azure devices client, and we also need the device to be shared. So we will add a package for that as well then. So let's say .NET again, add, okay, with the package Microsoft Azure, okay, devices, yes, and it has to be shared. So say share. And finally, let's put up the Newton's of, okay, so Newton soft.json, and let's get this added. Now we have created a directory, right? Let's try opening up this folder. Okay, so you say open folder and you will open up the firmware update device that we have. So let me say open folder and see we have the gap, okay, that we have. Let's open up this. Now you can find the .NET core app which I have created, okay, the console app. So you have the program.cs for the same, okay, and you have the other files as well. Let's go with program.cs. Okay, and here I will put up the solution code that we need. Okay, let's first say I need to restore all these things. Let's say yes to get it updated. And let's add the code now. Okay, so probably I will share this code. You can follow Kasam. Okay, he has a channel, right? Probably on the YouTube, or you'll be sharing it on the LinkedIn with the solution files and also with like the library files that you need to try this demo. So see, I'm here writing up a code, okay? And what this code actually does for you is that I have added it on the command file as well. It's going to call up all the library files which you created, and it's going to call the simulator device with the connection string. So you'll be calling the device, the sensor device, like TH, right? Some numerics that we gave, and it's going to write the device ID, and it will verify the device status here. So the device status, like the current firmware version that it's using, the pending firmware version, if it has not been installed with anything or not. Okay, the latest version that we have, the last status, the update that it has done, and you also have the twin collections which can be reported with the properties. And at top of it, we also have the console. You have the console which says that the file that gets downloaded, okay, and the time metrics that gets delayed for the firmware update to get downloaded. So when there's a change that happens, when there's a change on the firmware update that you do it on the portal, it can get uploaded to all the billions of devices that you're going to connect, okay, with your IoT hub environment. So here, let me scroll. I would say I need a connection string to be added up when I run it. So let's save this. Okay, and you can try running this. Okay, start the device simulator by going up here with the terminal. So let's say open with terminal here, and we would say .NET run. Okay, with the device connection string. So Here I have my connection string on my notepad, right? Let's take this and we shall say run this with the connection string and your IoT hub to be called out. So you just say this and you can say the device getting booted on. So here is the device which gets booted and the current firmware update version is also given up here. So now there is a device and it has a firmware update version. Now let's test it. Okay, we will create a device configuration and we will check giving up firmware update for the same. So let me go with the portal now. Okay, so here is my Azure portal and I have my IoT hub. So scroll down, you can find the device configurations. Okay, in automatic device management, you can find the device configuration. And let's add the device configuration here. I'll say add device configuration and let's name it here. Okay, I will say it's going to be a firmware update, right? And let's go for the twin settings. So here in the twin settings, let's say the changes that we're going to do for it. So here for the twin settings, enter the properties like it's going to be properties dot desire, okay, firmware. So this is my device twin property. And let's put up the version as well for the same. So here is the version. Now, see, we are going to come up with the next version of the firmware. It's going to generate a package as well. Okay, the version is going to be 1.0.1. And this has to be pushed for all the devices that we have within the IoT hub. So let's say go to the metrics, okay, and put up the query here. Let me say firmware updated, okay, for the metric name. And here for the metric criteria, let's give up like, see, you have a syntax which has been given. So say select device ID from the devices where properties you have reported with the firmware, current firmware version that we are going to release. And next, go to the target device. You need to collect the target device. You say priority to push it across. Okay. And target device, you can say device ID here equal to, it was sensor something, no? Let me check it. Give me a moment. It's sensor TH0155. Okay. So you give up here as sensor TH, okay, 0155. Yeah, that makes sense. And let's say view devices. There we go. Now let's push this firmware update for the devices. Now, if there's like millions of devices, you can select it here. You just push it across, okay, at one stand. You say create, you put it on the query update, okay, and ideally what you can see is that, see, it got created, 0 targeted and 0 applied, okay, you find the system metrics over there. And now you go to the IoT hub, sorry, the metrics, okay, over here. See the current firmware version that you have, the desired property has changed and the firmware update is also getting changed here. So this is how you can do an automated device management for any kind of sensors. This is a simulated sensor that we have for temperature. So in case if you are going to speak about light or fan, you can call the device ID in real time, okay? And you can keep the firmware to be updated on the IoT hub. It has to use a standard tier again, and you need to come up with a versioning as well for the same. Okay, you will be maintaining multiple versions just to make sure that you will not get a conflict. And you also need to make sense about the three device management principles, like either you go with a device twin, okay, direct call, okay, or the other way is that you do cloud to device messaging. So there are like there are three approaches that you can use for the same. Cool. So with that, we come to an end for this, right? You can let me know if you have any questions the last 15 minutes from now on. Okay, if you have any questions on implementing this IoT stuff. Okay, cool. So I hope you should be getting the recording from Kasam. Okay, and you can again keep me written with these details in case if you have any questions across. So you can reach me over Dear Azure. Okay, you'll be having the Twitter handle of Dear Azure on which you can follow, or you can even follow on LinkedIn or even the YouTube channel. You can keep a comment to be posted there. Well, thank you so much for joining again, then, and happy learning, everyone. You have plenty of events going across with Global Azure, with other user groups as well. Feel free to join and have a good learning as well. Thank you very much.